All right, problem number 4A. We need to factor all this fun stuff and then graph this rational function and identify all the pieces. So let's think about how we're going to factor this. So look at the numerator. We have four terms there. Again, that's your hint that you're going to be using factoring by grouping, or at least you're going to try factoring by grouping. Won't always work for you. So look at these first two terms and see what they have in common. Well, they both have an x squared. So we're going to pull out an x squared, and we're left behind with 2x plus 1. Just like that. Oh, hey, look, that's in our denominator. Interesting. So now let's look at that next part, the negative 2x and the negative 1, and notice there's an addition sign in between there that I'm writing since I'm including that negative. Now here I can factor out, well, not much, essentially just a negative 1, which is actually a good thing because if you will remember what we're trying to accomplish with factoring by grouping, we're trying to get this to happen, 2x plus 1. We want to have the same factor in each because now we can factor out the 2x plus 1. So if we do factor out a 2x plus 1, well, we're left with an x squared minus 1, which can be further factored as x plus 1 times x minus 1 because that is a difference of squares. So that is my numerator right there. And now let's go through and let's look at what the denominator is going to give to us. So I'm just going to continue underneath there. Well, first off, I still have that 2x plus 1 factor hanging out. I'm going to leave that alone because that's going to cancel with the 1 in the numerator. But then that x squared minus 6x plus 9 will indeed factor as x minus 3 quantity squared. And this is all equal to our function y. And let's identify the key pieces here. So first off, notice I have that 2x plus 1 in the numerator and in the denominator. Those are going to cancel each other out and give us a whole in our graph at x equals, think about where that's going to happen, 2x plus 1 equals 0. That's going to happen if you finish this through when x is negative 1/2. So that is where our whole is going to happen. For zeros, look at your numerator. You're going to have zeros when the numerator is equal to 0. So we have x plus 1 and x minus 1. So we're going to have zeros at x equals plus or minus 1 in this case. And then finally, we are going to have a vertical asymptote. I think I said tope. My bad. And that's not an at symbol, but that's what it's trying to be. A at x equals positive 3, because positive 3 makes the denominator 0. And notice that the multiplicity on that is 2. That's going to become important when we sketch it. So I'm going to make my note here that it's a multiplicity 2 for that vertical asymptote. And then finally, let's think about if there's going to be a horizontal asymptote for this problem. Now, to answer that question, you need to think about what this function would look like, what the degree of this function would be if you multiplied everything together. Well, in the numerator, if you multiplied everything together, you're going to get a highest degree of 2x cubed. And in the denominator, you're also going to get a highest degree of 2x cubed. And that's telling me that I am going to have a vertical asymptote at y equals 1. And I said vertical asymptote, but I meant to say a horizontal asymptote at x equals positive 1. Because you have to think about what happens when x gets really, really big, or when x gets really, really big in the negative direction. Well, you end up with this fraction that is approaching 1. It depends on where you are in your graph to determine which side of it you're on, but it's a horizontal asymptote, so you will never cross it. And I said vertical and meant to say horizontal, and I wrote x and meant to say y equals 1. So my bad, I keep messing stuff up. But let's do this and see what happens. So everything's happened pretty close together, so I'm just going to go 1, 2, 3, 1. No, I'm going to make those a little smaller. Actually, wait, I can just scoot over. So 1, 2, 3. I'm going to call that a 4 there. And then 1, 2, 3, 4. And let's mark what we know. We know we have zeros at positive and negative 1. So we're going to have real zeros right there and there, positive and negative 1. I know I'm going to have a vertical asymptote at x equals 3. So I'm going to dash that in. And I know I'm going to have a horizontal asymptote at y equals 1. So I'm going to mark that in as well. And let's see, is there anything else? Oh, I have a hole when x is equal to negative 1/2. So I'm going to set a little reminder for myself. Looks like right there. How about? And we'll see what happens. Now there are many different ways you can think about graphing this. You could plot the numerator and denominator and see if that helps you. But there are a lot of clues on this board right now as we have it drawn that can help us. One big clue is that we only have 2 zeros at negative 1 and positive 1. So that tells me when I'm over here all the way to the right, this branch has to be up like that, because if it were down like that, it would have to cross the x-axis, and we know it doesn't cross the x-axis. So that helps us there. Now, we also know that the multiplicity at that vertical asymptote, that denominator, x minus 3 quantity squared, tells me that my tails at this asymptote are going to be together. So we actually have an interesting case here where we're going to come down and we're going to actually cross our asymptote. We're going to cross the x-axis, go through those 2 zeros, and then level up back towards that value on the underside. And I almost forgot, as I often do, to put that hole into my graph. So notice I've added that right there, that hole at x equals negative 1/2. And this should be a pretty semi-decent sketching of this graph.